Hello friends, this is an introductory lecture about the different concepts in statistical inference and estimation. See, first concept is random variable. What is random variable? Random variable is a function whose domain is a set of the sample points and range is a set of real number. As range is a set of real number, therefore it is a real valued function. See, random variable is a real valued function whose domain is set of sample points and range is a set of real numbers. Okay. Then random sample. What is random sample? The set of n IID random variables. See now again set of this set of n, that is x1 x2 up to xn, 1 2 up to n. How many there are? N. Set of n IID. What is IID? Independent and identically distributed random variables. X1 x2 xn, these are random variables. Set of n IID random variables, independent and identically distributed random variable, okay, is called as a random sample. Then next, what is the realization of random sample? The values that a random variable can assume, this is called as a realization of random sample. That small x1 x2 xn are realization of random variable. Okay, these are the values actually assumed by the random variable. You can also say that the values actually assumed by the random variable is called as a random realization of random sample. Okay, then parameter, the basic and very important concept in the statistic or inference. Okay, parameter. What is parameter? Parameter is the quantity which specifies the probability distribution completely. Parameter is a quantity regarding the distribution which specifies the probability distribution completely. See, in binomial distribution parameter is p, in Bernoulli distribution is also p, in Poisson distribution is lambda, in normal distribution mu, etc. These are the different parameters. Okay, and what is parameter space? Parameter space is the values which are actually assumed by the parameter or the interval. It will be the interval also. It will the values assumed by the parameter is called as a parameter space, or the value which parameter takes. Also, you say that value the parameter takes is called as a parameter space. And what is the support of random variable? See, the values that which random variable take is called as a support of random variable. See, by the from an example we learn it. Okay, for example, Poisson distribution. Okay, Poisson distribution. See, what is the PMF? Probability of x equals to x is equals to e raised to minus lambda, lambda raised to x upon x factorial, where x is equal to 1 2 up to n, and then what is the parameter space? Lambda is greater than 0. See, this is the parameter space, this is support, this is your parameter, this is your random variable. X is a random variable, lambda is your parameter, lambda greater than 0. What it means that lambda belong to 0 to infinity. Okay, this is the interval. Okay, this is the parameter space denoted by script h. You will say that script h is equals to 0 to infinity. असं पण तुम्ही म्हणू शकते, असंही आप कह सकते हैं. You can also say that. Okay, then support of random variable. What is support of random variable? The values which the random variable takes, that is x equals to 1 1 2 up to n. Okay, as it is a discrete distribution, therefore that will be write it as, for continuous distribution we write as this way. Okay. See, now the different again another concept is that statistic and statistics, these are really two different things. Okay. Statistics, what is statistics? It is a collection, presentation, interpretation of the analysis, interpretation of the data, the whole, and in that statistics comes your parametric inference. Statistic, what is statistic? Statistic is also a real valued function of random variable, a real valued function of random variable. Okay, x1, x2, xn, which is free from unknown parameter, which is free from unknown parameter, that it contains the all the parameters you know. In simple language, easy to compute, always computable, its value always be find. Okay. See, statistic, for example, x bar summation xi upon n, that is x1 plus x2 plus x3 up to xn upon n. Statistic. See, I want to collect it. I take 10 sample from this class. Okay, 10 sample of 10 students, and take their sample of heights. Okay, first height, second height, third height, up to 10 students height. Other thing I don't know, only take height and find its mean, average, arithmetic mean. In this way, okay, you will get a particular value. See here, S square, what is it? Sample variance. And what is it? It's a population variance. Sample variance is a statistic, but population variance is not a statistic. Why? See, in sample variance, you know n, that is 10, you know xi, you know x bar. How? This way. Okay, from that 10 samples you can compute it x bar. Okay, but in population variance, you know n, you know xi, but you don't know this mu. What is it? It's a population mean. Okay, you don't know the population mean. What is the mean of that population? No. If you know that, then you are not interested in that estimation. Okay, you already know. Then this is different. Therefore, this is difficult to calculate the mean of whole population. It is very difficult. Therefore, we use sampling. This is the purpose of estimate. This is the estimation. Okay, and for that we are using it. And here we don't know the population mean, and therefore we say that population variance is not a statistic. Okay, it's a function of random variable, but it contains unknown parameter. What is it? Is unknown for us. Okay, unknown. Therefore we say that it is not a statistic. Okay, then we find again the probability distribution. Probability distribution of statistic. Probability distribution of statistic. Here, see, x is a random variable. Okay, we find its probability distribution. See here, t is a random variable, or t is a statistic. Okay, then we find the probability distribution of that statistic. For example, you want take t is equal to x bar, then we find the t follows normal mu comma sigma square by n. How it comes, we will see in that estimation. Okay, next topics. Okay, this way. What is standard error? That is standard deviation of statistic. What is standard deviation here? Standard error of t is equal to sigma by root n. What is standard deviation? Okay, square root of variance. In this way. Okay, any problem here? No. Then estimator. See, estimator is also a statistic, and not statistic is also a random variable, function of random variable. It may be a random variable also. Okay. Statistic is a random variable and estimator is a statistic. Note that. Estimator implies statistic implies random variable. Note that. These are the basic concept which are difficult. Many people have difficulty about that and no concept knowledge about that. Okay. See, estimator implies statistic implies random variable. Okay. See, what is estimator is a statistic whose distribution concentrate as closely as possible to the nearest value of that parameter. Okay. It's a function of sample related to the some quantity distribution. See, in short, E of t equal to theta. Okay, here it's a mu. See, for example, mu. E of x bar equal to mu. X bar value concentrates mu. Okay, see, we have to estimate. We don't know the population mean of this class, height of this students of this class. No, we don't know. Therefore, we are taking a sample and sample of 10 students, and we find the height of that sample, height of the students, each student, and find the mean of that height. Okay, this mean. Okay, suppose it will get 9.9. Okay, and your population mean is estimated is to be 10. Suppose that. Okay, is closely to. Okay, it's a point estimate. That x bar is a point estimate for estimator for mu. Okay, this 9.9 is estimator. And if I say that the value of population mean will be lies in between 9.5 to 9.8. Okay, 9.59 to 9.98. Okay, if I give an interval to you, then it will be the interval estimate. See, this is about the point estimate and interval estimate. That a particular value you get is your point estimate, and the value comes in the interval is your interval estimate. Okay, this is about the point estimate and interval estimate, and about the estimator. Please remember that every estimator is a statistic and every statistic is a random variable.